Section 3.5, solving two-step equations. All right, so what we have done before, I've shown you how to solve an equation that's adding. I've shown you how to solve an equation that has been subtracting. We've shown you how to solve an equation that's been dividing. We've shown you how to solve an equation that has been multiplying. But now, what happens when you have a combination of multiplication and addition? Or an equation with division and subtraction, or anything thereof? Well, this is why I showed you this way. I showed you subtraction and addition first, because that's the first thing that we have to do to solve an equation. And then I showed you multiplication and division second, because that's what the second step is to solving a two-step equation. First, this is why I like SADMEP. Our first step is to get rid of subtraction and addition. That is the first thing we got to do. Notice I even got a 1 and a first right after there. It is so important that you understand. In order to solve an equation that's a two-step equation, we first have to get rid of either the addition or the subtraction. Okay? Then the next thing is to get rid of the multiplication and division. So that's what I mean by SADMEP. I'm reverse engineering PEMDAS. I got to get rid of these guys first to solve my equation. Once I'm done with that, I have to get rid of these guys second. And then this comes later. Again, this is something for another day. This is all we're talking about, the two-step equations. So with that said, that's the basic definitions. What in the world is a two-step equation? Well, bam, right here. This is what a two-step equation looks like. Look at what I have. I have in front of me, I have a variable with a coefficient, and on top of that, I also have another statement. So this is an expression, and it has two terms. One term has a variable, the other term does not. All right, and then on the other side, it's just equals to a very simple expression. This is a two-term equation. All right, it is a two-step equation. All right, so how do I solve this? Well, we are going to solve for A by SADMEPing it. We are going to SADMEP it. The first thing that I have to do is get rid of either the subtraction or the addition on this expression, on this side of my equation. So this expression has a -5. So how do I get rid of a -5? Well, just like the first thing that we did back in 3.3, we have to do the inverse operation, which is addition. So I am going to plus 5. And when I do, the -5 and the +5 cancel out, and what's left is the 3a is equal to. And now, just like before, what I do to one side, I must do to the other. So I have to add 5 to the other side of my equation. So -14 plus 5 gives me -9, and I write that down. So I just turned this from a two-step equation, and now it's gotten into familiar territory. Hey, this looks like a one-step equation where I have to use multiplication and division. So I've just finished the SA part of SADMEP. I got rid of the addition and the subtraction here on this expression for here. Now that I have done that, my expression changed from 3a minus 5 to just 3a. So now my equation says 3a is equal to -9. So now that we've done the first part, we do the second part by getting rid of either the division or multiplication. So what is happening here? This is saying 3 times a. This is multiplication. And to get rid of multiplication, we must divide. When I do, that cancels out and leaves me with just a. bring down my equal sign. And just like before, and just like always, if I do something on one side of the equation, I must do it to the other side of the equation. So negative 9 divided by a positive 3 gives me negative 3. So I found out that A is negative 3, but I don't know if that's true or not. So we have to take this number right here and plug it back into my original equation. So I'm going to say 3 times a negative 3, because 3A, 3 times A are negative 3. 3 times negative 3 minus 5 is equal to negative 14. Now, since we're trying to verify this works, we actually use our order of operations for this side of our equation. We're going to use order of operations. Please excuse my direct Sally. Hey, that's pandas. So 3 times negative 3 gives me negative 9 minus 5 is equal to negative 14. Now, what's negative 9 minus 5? Well, let's find out. Negative 9 minus 5 is negative 14. So, does this check out? Yes, it does. So my answer is indeed A is equal to negative 3. All right? Now, let's look at our next one. I have 10 is equal to negative 2C plus 21. So how do I solve for C? What is C? I got to figure it out. Well, what do? I SADMEP this thing again. My job is to get C by itself by getting this expression and removing these numbers from this expression and moving it to the other side of my equation, just like before. So, with that being said, let's go ahead and do it. My first step is to get rid of my subtraction and addition. So what's being added here? The plus 22. So how do I get rid of it? I do the opposite operation and I subtract 22. That cancels out. I bring down my negative 2C and my equals. And this has to be, since I've done it on one side, I must do it on the other. So 10 minus 22 equals negative 12. Now that I've done that, I need to continue doing SADMEP. I've finished my subtraction addition and I've gotten rid of it. And all that's left now is my multiplication and division. How do I get rid of it? Since this is negative 2 times C, I must divide by negative 2 on both sides. When I do, this cancels out and just gives me C. And negative 12 divided by negative 2 is a positive 6. Okay? Now, is this true? Well, let's plug it back into our original equation. 10 is equal to negative 2 times 6 plus 22. 10 is equal to, well, negative 2 times 6 gives me a negative 12 plus 22. And then if I add that together, I do get 10. So plugging this number back into my original equation gets me the correct answer that C is equal to 6. All right, I am going to do one more with you, and I'm going to do the one that I know is already scaring you because, SpaghettiOs, that's before your time. That was an old commercial I used to listen to. This right here is fractions, the deadly fractions that you don't love at all. But just because it's a fraction doesn't mean anything. It's still a number. You don't change the procedure. Look what's happening. This is saying negative 5/11 times h plus 7/9 is equal to 2/9. Now, with that said, what do? Well, we SADMEP it. So we get rid of the subtraction and addition. And in this case, again, I have an addition. So in order to get rid of this positive, this adding of 7/9, I am going to subtract 7/9. That will cancel out. And what that leaves me is negative 5/11 times h is equal to. And since I subtracted 7/9 on one side of the equation, I must do it on the other side of the equation. Now, when I do, 2/9 minus 7/9 will give me a negative 5/9. Don't believe me? Let's find out. 2 ABC 9, 2/9 minus 7 ABC 9. So that gives me 2/9 minus 7/9 gives me negative 5/9. Now, what do I do? It's multiplying here. It's still a number, so I'm going to multiply negative 5/11 times h. So how do I get rid of it? I'm going to divide on both sides. And this cancels out, and I get h. So this looks complicated right off the bat, but I'm going to do a little scrap work because you remember why we spent so long working with rational numbers and multiplying and dividing fractions? This is why. I have negative 5/9 divided by negative 5/11. So what I'm going to do is I'm going to do this on paper first, and then we'll do it in the calculator. Remember your rules with fractions. When you are dividing fractions, you keep the first number, you change, and then you flip. Keep, change, flip when you're working with the fractions. Now that you've done that, before you do anything else, why don't you cross-reduce? Notice that the numerator of this one and the denominator of this one are the same. So, hey, I can reduce these both by 5 and divide that. That would become a 1, and that would become a 1. This can't do anything. But now that I've done that, I can multiply. 1 times 11 is 11. 9 times 1 is 9. And since they were both negatives, I should have an answer of 11 over 9. So h is 11 over 9. Now let's see if Mr. Lewis got his work correct. I knew that I was going to go negative 5/9, so negative 5 ABC 9 divide by negative 5 ABC 11. And when I do, I get 1 and 2/9, but that doesn't match what I have. Well, let's find out. If you remember, I've shown this to several of you before. If you look right here, it's got A, B, C, and 2 arrows, D, E. This is going to be a way I can take this calculator and change this mixed number and put it into an improper fraction. So I can say it second, ABC, and it's going to take that answer and change it into the improper fraction of 11/9. So it does work. So we've done that. But we have not checked our answer. I've just proved that my math over here on my scrap work was correct. We still need to find out if 11/9 is correct. So I have to plug this back into my original equation, and I'm going to have to write it up here because I ran out of room. I didn't mean to be this sloppy. I apologize. So I'm going to say negative 5/11 times 11 over 9 plus 7/9, and that should be 2/9. So I'm going to follow my order of operations. That's a lot of fractions, and I don't even want to do that right now in paper. So I'm going to say negative 5 ABC 11, and I'm going to multiply that by my answer of 11 ABC 9, and I get this number. But now that I've done that, I have negative 5/9 plus 7/9. Let's see if that works out. So I'm going to add my 7 ABC 9s because I'm working it all the way through. And I found out that this entire thing does work out to 2/9. So this is indeed my answer. Yes, this one was more complicated because it had fractions, but the procedure remains the same. You follow SATMAP, and you do have access to a calculator to help you with these fractions. They are not that difficult if you remember. They're just a number. All I got to do is put them in my calculator to help me out. Now, with that said, why don't you try numbers 3, 4, and 5 on your own? So, What you should have got for 3 is b is equal to -7. For 4, z is equal to 3. And for 5, n is equal to -6.9. If you are not sure how to do these problems, I'm begging you, please come ask me or somebody in class to see what you may have done wrong. Please, please, please do that. All right. 7. The length of a rectangle is 3 meters less than twice its width. Ooh, this is a tough one because right there is a lot of information. So let's look at the part A. Write an equation. Oh no, write an equation to find the length of a rectangle. All right, so let's look at this. The length of a rectangle is, stop right there. That right there is saying this, the length. We're going to say, we don't know what the length is, but I do know this, that I can put a variable for it. So we're going to say the length is. The length of a rectangle is. That one piece right there is literally the first part of your equation. Length, L, is. All right. Then it goes to this. 3 meters less than twice its width. Pause. You remember back in the very first, I think it was 3.3, when you see that less than, you have to think backwards. So automatically, this right here is subtraction, and we know this is 3, so we have to think backwards. So that's going to be a -3. And then it gives me twice its width. Well, what does that mean? Well, twice. Well, that's double. That's 2 times. And we don't know what width is, but we can put a W. So 2W. The length of a rectangle is 3 meters less than twice its width. Wow, it is confusing. I will admit that. And this is one of the things about the English language and mathematics that don't get along. And this is where it gets so difficult. But remember, if you see some key context, like the word is, that's generally going to say equals. And if you see this right here, like numbers less than something, that means that you're going to be probably rewriting in reverse. And twice its width is basically multiplication. Now that we've wrote our equation, length is equal to twice the width minus 3. So now let's look at B. The length of a rectangle is 11. What is the width of the rectangle? Hey, wait a minute. How do I do that? Well, if I know this equation and I know that the length is actually 11, I can take this number and plug it in to that L. So I can rewrite it and say 11 is equal to 2W minus 3. Hey, now we're in familiar territory. So what do? It is a 2-step equation. We SADMAP it. Let's get rid of subtraction and addition. And in this case, it's subtracting. So in order to get rid of it, I must add 3. And if I do it on one side, I must do it to the other. So that would cancel out and brings me with a 2W down. 11 plus 3 gives me 14. Now I have 14 is equal to 2 times W. How do I get rid of multiplication? I divide. That cancels out and I get that 14 divided by 2 is 7 is equal to W. Now we can kind of prove this by plugging this back into our original equation. So we can say L is equal to 2 times 7 minus 3. That's going to be 14 minus 3. And L is equal to 11. Is this true? Well, yes, because that's what our word problem stated, is that the length is 11. All right, as always, you know where to find me. You know how to ask questions. Please do. And I will see you in the next video. Bye-bye.